In this related rate problem, we have a car at point A that's traveling north at a speed of 45 miles per hour, and we have a car at point B traveling west at a speed of 60 miles per hour. They're both traveling toward the same point C. Car A starts 22.5 miles away from point C, and car B starts 30 miles away from point C. So if you think about the speeds that they have and the distances to travel, they're both going to reach the point C at the same time. We're not going to worry about what will happen then. What we're going to try to do is answer the question, how fast are these two cars approaching each other at the point that we see here in the picture? So if we think of the distance between B and C as x and the distance between A and C as y, then we can call the distance between A and B, the hypotenuse of a right triangle, h. What we're really looking for then is dh dt. How fast is the distance between the cars changing? So since we have a right triangle and we're looking at all four sides here, it might be useful to consider the Pythagorean theorem. So we can write that x squared plus y squared is equal to h squared. If we take derivatives of both sides of this equation with respect to time, we'll end up with 2x times dx dt plus 2y times dy dt is equal to 2h times dh dt. And if we divide everything on both sides by 2, we'll get x dx dt plus y dy dt is equal to h dh dt. Now we're trying to find dh dt, so what we'll do is divide everything on both sides by h. I'll flip things around here a little bit, and we'll find out that dh dt is equal to x times dx dt plus y times dy dt, all divided by h. So we need to see if we can find values for x, dx dt, y, dy dt, and h. Well, most of these are given in the problem we see here. We can see that x is 30 miles an hour, and we can see that dx dt is going to be a negative 60, and we're going to make this a negative because this distance x is going to be decreasing. So we want to have our rate of change be a negative to show that the value of x is decreasing. Similarly, on the left-hand side of the triangle, the distance y is going to be 22.5 miles. dy dt is going to be negative 45 because y here is also decreasing. It's becoming shorter as time goes on, so we'll think of that as a negative 45. The only thing that we don't know here is h, but we have a formula for h right here with the Pythagorean theorem. So let's go over to the side here and write for a moment that h squared is going to be equal to 22.5 squared plus 30 squared. And if I pull out my trusty calculator and figure out what 22.5 squared plus 30 squared is, I find out that h squared is equal to 1,406.25. If I take the square root of that, I will find out that h itself is equal to 37.5. That's going to be in miles, and that is the hypotenuse of our right triangle. Now when I solve that equation, I also get an h is a negative 37.5 miles as well, but obviously in the way we've drawn the picture and the way we're thinking about distances, a negative distance doesn't really make much sense. Now let's take and plug our numbers into our equation here. dh dt now is going to become x, which is 30, times dx dt, which is negative 60, plus y, which is 22.5, times dy dt, which is negative 45. We're going to divide all of that by 37.5. And let's see, if I do the numerator, 30 times a negative 60 plus 22.5 times a negative 45, I get negative 2,812.5. Still need to divide that by 37.5. And if I do that division, I find out that dH dt in this problem is negative 75 miles per hour. The negative implies that the distance h is decreasing, and that makes sense. We already know that x and y are decreasing, so the whole triangle is getting smaller, so h will decrease as well. And they are approaching each other at a speed of 75 miles per hour. Now, they're not driving directly at each other, but that is the rate at which the distance between them is changing.